The vastness of space contains a mysterious and exciting universe. Humanity has been looking up at the heavens with fascination for a long time, trying to figure out what mysteries exist beyond our little blue world. Our search for knowledge has now come to a critical juncture. The James Webb Space Telescope, outfitted with unmatched sensitivity and precision, has set its eyes on a world that has fascinated scientists and dreamers alike. However, what precisely is Proxima B, and why are its mysteries still hidden in the vacuum of space? Come learn about how the James Webb Telescope recently captured the most lucid image of Proxima B to date. Galaxies formed when the cosmos first came into being billions of years ago. The James Webb Space Telescope, JWST, is a cutting-edge instrument that we now have that may enable us to explore the furthest reaches of space. It sees things we've never seen before utilizing infrared glasses, as opposed to using normal sight like our eyes. It's similar to witnessing an entirely new universe after donning magic glasses. Scientists can investigate the origins of galaxies, stars, and planets with the help of the JWST. They can even use it to observe planets outside our solar system in an effort to find evidence of extraterrestrial life. With the use of the JWST camera, which has amazing filters, scientists may record various hues of light to discover more about the universe. And what do you know? It has found some really interesting things. For example, it discovered that the universe has far more mass than previously believed, concealed like treasure in massive galaxies. Thus, one galaxy at a time, we are deciphering the mysteries of the cosmos with the aid of the JWST. However, there's more. The best image of Proxima B was recently released by the James Webb Telescope. In 2013, astronomers made the startling revelation that there was a minute pull, similar to a mild tug, between a planet and its star. Because it orbits Proxima Centauri, the star system that is nearest to Earth after the Sun, this planet was subsequently designated Proxima B. It's similar to making new friends that live next door. The distance between Proxima Centauri and the Alpha Centauri system is approximately 4 light-years. This implies that it's as if we're looking back in time when we look at it. We're seeing it as it was 4 years ago. In contrast, Proxima B is one of the nearest planets outside of our solar system, even though it is only 25 light-years distant. Can you picture traveling to a new world that is so near to your own? Proxima B is roughly 30% more massive and slightly larger than Earth. The fascinating aspect, though, is that a year on Proxima B only lasts 11.2 Earth days. This is due to the fact that it orbits its star extremely closely, just 7.3 million kilometers, which is much closer than Earth does to the Sun. Despite being so close, Proxima Centauri is a small star with less heat output than our Sun, so you may expect it to be unbearably hot. So, how would one feel if they were to stare up at Proxima Centauri from Proxima B? Would the color of the sky change? Would the star appear larger? Scientists are eager to investigate these kinds of questions as they gain more knowledge about this amazing world. Imagine staring up at Proxima Centauri, the star of Proxima B, from where you are standing. Proxima Centauri, around 3 times larger than our Sun, would appear as a large, dull red orb in the sky as opposed to the dazzling yellow sun that we currently have. Interesting, huh? Liquid water may exist on Proxima B if it is in the Goldilocks zone of its star, which is defined as the ideal temperature range between hot and cold. Water in liquid form is vital to life as we know it. However, there are a few things you should be aware of before you begin organizing your space trip. It seems likely that Proxima B is tidally locked to its star, meaning that one side of it is always illuminated while the other is always in the dark. No living creature could be comfortable like that. Furthermore, the star's intense radiation would heat up and transform any planetial water that approached it too closely into steam. Conversely, a planet that is too far from its star would be extremely frigid, causing all of the water on it to freeze solid. It's possible that Proxima Centauri isn't the greatest host for life. Its nuclear fusion cores are closer to the surface while being considerably smaller than our Sun, which results in a great deal of turmoil and turbulence. Strong magnetic fields produced by this turbulence have the potential to release hazardous radiation and particle bursts, which would be difficult for planets in the habitable zone like Proxima B. Scientists now have a greater understanding of the magnetic field surrounding Proxima Centauri than they had before, owing to a recent study that made use of sophisticated mapping. According to the findings, Proxima B receives almost 1,000 times as much radiation from the star's solar wind as Earth does, which could be dangerous for any potential life. Proxima Centauri, the star next to Proxima B, saw a megaflare in April 2021. A megaflare is an extraordinarily strong outburst of radiation. This flare outperformed all previous flares observed from our Sun by a factor of 100. Imagine how intense and brilliant that must have been. It is difficult to believe that anything could withstand such a radiation assault without additional safeguards. Though it's fascinating to consider that a planet like Proxima B could be a cozy place for life to exist, the truth is probably not so pleasant. Living organisms would probably have extremely difficult conditions there. We have long been fascinated by the prospect of encountering extraterrestrial life. When a peculiar signal was discovered in late 2020 emanating from the Alpha Centauri system, home of Proxima Centauri, it piqued our curiosity. The frequency of this signal, 9,182.5 MHz, is intriguing because it differs from the frequencies that are typically heard from our satellites and probes. While some specialists believe it could be from a piece of machinery, others are hopeful that it could be evidence of sentient life somewhere in the universe. There may be water vapor in the atmosphere of Proxima B, the distant planet scientists have been investigating, according to new data from the James Webb Space Telescope. Water is essential for life to exist, thus this is significant. Determining whether water exists on Proxima B is similar to figuring out a large jigsaw in space. Scientists are studying Proxima B's atmosphere from a distance using a variety of cutting-edge techniques, including atmospheric modeling and spectroscopy. Spectroscopy is akin to use a sophisticated espionage tool to identify the gases present in Earth's atmosphere. It can assist us in determining the presence of elements that are necessary for life, such as carbon dioxide, methane, and oxygen. Then there's atmospheric modeling, which is akin to creating a computer-generated model of Proxima B's atmosphere. By experimenting with several theories, scientists can discover potential occurrences on the planet. It's similar to modeling a dinosaur and speculating on its appearance during its era of extinction. Together, these instruments are beginning to provide scientists with a better understanding of Proxima B's atmosphere and whether or not it would be a suitable place for life. However, we still have a lot to learn, so we must never stop researching and learning new things. Proxima B is close to its star, which complicates matters, but we shouldn't abandon up. After all, there are examples of life thriving in harsh environments right here on Earth. Extremophiles are microscopic organisms that can survive in extreme environments, such as bitterly hot deserts or deep inside the ocean. Given that life has managed to survive in harsh environments on Earth, imagine what may be achievable on a planet such as Proxima B. Extremophiles are little organisms that resemble superheroes of survival that exist on Earth. They inhabit environments that were long thought to be uninhabitable, such as incredibly hot springs, lakes containing acid, deep-sea vents that erupt boiling water, and even Antarctica's icy ice. These resilient little fellas have demonstrated to us that life may exist in unexpected locations. Extremophiles inspire optimism that life may exist beyond our solar system, such as on the far-off planet Proxima B, which we are now exploring. Perhaps there are living beings that can survive in harsh environments on other worlds, much as these creatures do on Earth. We have discovered a wide variety of extremophiles on Earth. Thermophiles are happiest in warm environments and can endure temperatures that would cause us to perspire. There are two types: Pyrococcus furiosus, which hangs out in extremely hot deep-sea vents where the water is hotter than boiling, and Thermus aquaticus, which lives happily in hot springs. And then there are the champions of frigid love, the psychrophiles. These organisms are able to withstand extremely low temperatures. Psychrobacter arcticus, for example, thrives in the frigid climates of the Arctic and Antarctic. These extreme organisms are nature's method of demonstrating to us that life persists despite adversity. On Earth, there are other kinds of extremophiles that are equally fascinating. Acidophiles, such as Acetobacter ferrooxidans, enjoy thriving in acidic environments. They flourish in conditions that would disintegrate the majority of living things. Then there are alkalophiles, which live in extremely alkaline environments, almost as they are living in baking soda, Natronominus ferraeones. Last but not least, There are halophiles, such as Halobacterium salinarum, which inhabit extremely salinized environments like salt flats. These animals demonstrate to us the adaptability of life, making them seem like superheroes of survival. Considering the difficult circumstances on Proxima B, such as the high radiation levels from being so, proximity to its star raises the question of whether extremophiles may also live there. Extremophiles on Earth give us hope. Consider the bacteria Deinococcus radiodurans, which can withstand radiation exposure hundreds of times greater than that which would kill a human. These extremophiles have developed fascinating survival strategies, such as distinct cell architectures, defensive pigments, and specialized DNA repair systems. These adaptations hint at possible ways in which life may adapt to the harsh environment of Proxima B. It would be astounding to find extremophile-like species on Proxima B that are able to withstand high radiation or other harsh environments. It would upend everything we believe to be true about the environments in which life may live, and perhaps even demonstrate that life can flourish in seemingly inconceivable places. Naturally, though, it's not as simple as it seems. It is extremely difficult to find life on other planets, particularly ones as distant and unique as Proxima B. For the purpose of learning more about this far-off world and its possible habitability, scientists will need to employ all of their knowledge and cutting-edge technology. Who knows? The potential idea of visiting Proxima B and investigating far-off planets seems like it would be extremely difficult due to several significant obstacles, so we might as well go there. Although our current telescopes, such as the James Webb Space Telescope, are intriguing in providing us with a glimpse into these distant worlds, their distance prevents them from providing us with exceptionally clear images or enabling us to conduct practical study. To overcome these obstacles, we must enhance our sensors and telescopes and perhaps even develop entirely new spacecraft. What if we could create new types of engines that would enable us to travel to other star systems considerably more quickly than we now can? This would allow for the exploration and discovery of an entirely new realm. Researchers are already exploring some fascinating concepts, such as solar sails that propel spacecraft forward by harnessing sunlight or ion propulsion that fires particles into space. Even the possibility of warp drives, as seen in science fiction, that could bend space and enable faster-than-light travel has been discussed. However, these are still only theories, and before we can utilize them to explore other worlds, much more investigation and testing are required. Still, considering the options is fascinating. Perhaps in the future, we'll have the technology to travel to locations like Proxima B and discover what mysteries lie there. Imagine being able to visit Proxima Centauri, the nearest star system to Earth, and having contact with extraterrestrials. Perhaps it's not as insane as it seems. Researchers at Breakthrough Initiatives are working to reduce the travel time from several centuries to a few decades, making ensuring a spacecraft can continue to accelerate as it approaches the speed of light, a very fast speed, is one of the major challenges. It would still take roughly 6,000 years to get to Alpha Centauri, the star system that is a component of Proxima Centauri, using present technology. The intriguing concept of using lasers to propel a spaceship toward Alpha Centauri is presented by the Starshot project. The tough thing is that Earth's atmosphere can interfere with the lasers, making it challenging to provide the spacecraft with the proper thrust. Lead scientist Bandhu Tunga believes we can solve this with a unique technology called adaptive optics. Small satellite lasers would monitor the atmosphere in real time, assisting larger ground-based lasers in maintaining their focus on the spacecraft. These lasers require enormous power, equivalent to all the electricity used in the whole US, yet they only need to be extraordinarily strong for a brief period of time. To send the spaceship on its course, they intend to deploy 100 million lasers dispersed over a large area. The spacecraft will accelerate across space at a startling 20% the speed of light after the lasers are switched off. It could travel to Alpha Centauri in just 22 years, which is faster than the lifespan of many people. It would be roughly 10 meters wide. The nearest star system to Earth, Alpha Centauri, presents several formidable obstacles to spacecraft visiting it. First, it might be significantly slowed down by the sun's attraction and space debris. It would take another 4 years for its signals to arrive on Earth, even if it makes it to Alpha Centauri. It's like to writing a letter and expecting a response years later. Researchers like Sibi and Bandutunga are putting in a lot of effort to make sure the spacecraft doesn't melt while traveling. They must ensure that the spacecraft's mirror is almost flawless, reflecting practically all of the light that strikes it. In order to prevent overheating, they must also cause the spaceship to rapidly reverse course and slow down. The fact that they can send more spacecraft at a fair price after they figure out how to launch one is one of the most intriguing aspects of this concept. This implies that they might investigate a greater number of star systems in an effort to identify planets similar to our own. Imagine the possibilities. We will have a completely new star system to investigate if we make it to Proxima Centauri. Who knows how many Earth-like planets are out there just waiting to be found? Thousands of exoplanets, planets outside of our solar system, have already been discovered by scientists. In 1992, they produced the first confirmed discoveries when they discovered planets circling pulsars, a unique kind of star. They discovered a planet circling a star similar to our Sun 3 years later. Numerous other planets have since been discovered, some of which are roughly the size of Earth and orbit stars in the Goldilocks zone. That is, in between too hot and too cold for life to exist. While space exploration is intriguing right now, you are even more enthralled with how the JWST found this planet. So how was the discovery made by the JWST? Situated approximately 1.5 million kilometers from Earth at a location known as the Second Lagrange Point, L2, the James Webb Space Telescope is akin to the Superman of space technology. That would be equivalent to more than 37 trips around the planet. As Earth orbits the Sun, the JWST's stable orbit is aided by its location near L2. It's similar to figuring out where in a parade to view without getting pushed around by the throng. The JWST is outfitted with an array of amazing instruments that are intended to solve the greatest riddles and reveal the innermost secrets of the universe. Searching for exoplanets, planets outside of our solar system, and determining whether any of them resemble Earth is one of its primary responsibilities. And the most thrilling thing, it will examine Proxima B, the enigmatic planet we have been discussing, in great detail. Infrared light, which functions as a kind of hidden code that allows us to view objects that are invisible to the human eye, is one of the light types that the JWST can use to snap images and collect data. Its main mirror, which is 6.5 meters wide and composed of 18 hexagon-shaped sections, is taller than 2 adults stacked on top of one another. This large mirror enables the JWST to capture far clearer images of exoplanets than any previous observatory, including Proxima B. The telescope's intriguing properties enable it to see objects that are extremely dim and far away. Consider attempting to spot a firefly glimmering in the distance. Because it helps collect even the smallest particles of light, the telescope's mirror size is crucial. This greatly improves the telescope's ability to view objects in space, such as the earliest stars and galaxies ever discovered, or even the weak glimmers reflected off exoplanets. For the first time, these small pieces of light are being collected by the James Webb Space Telescope and combined to create a crisp image. The problem with exoplanets, though, is that they function more like mirrors that reflect the light from their stars than they do like stars that shine on their own. Like stars in the night sky, they seem as tiny dots because of how little they are in relation to the immensity of space. If it weren't for two unique factors, we might never even be aware that these exoplanets exist. First, they briefly cause the stars to appear slightly duller as they pass in front of them. It's like a miniature eclipse in space. Second, they exert a very slight gravitational pull on their stars, causing the stars to slightly wobble inside their orbits. The planet and its star are engaged in a celestial dance that we can witness with the help of observatories like Kepler. The Kepler Space Telescope has been putting in a lot of effort to identify these oscillations and numerous eclipses. In the hundreds of exoplanets it has discovered while in space. We haven't had a chance to examine the region surrounding Proxima B up close up until now, but guess what? We are about to revolutionize all that with the JWST.